Hello, welcome back to another live stream. My name is Rafał and today we're gonna print with PET-G CF from the filament. So we can start unpacking it and we're gonna load it up on Prusa Core 1 because yes, that's the carbon fiber filament, right? So there is a bit of controversy around the carbon fiber filaments. We will talk about it in a moment. I'm gonna just put some quiet music in the background so we have something going on. We're gonna have this nice feeling for the stream. Let's have some fun today, guys. Okay, yeah, this is the ASA X. This is the carbon fiber 10% in ASA carbon black, but I don't think we're gonna have enough time to test everything today, so we will do the filament. The filament, there we go. This is it. The filament line, it's a very affordable way. Okay, we have some problems with the dark camera, but let me just fix it. It will be just a matter of few seconds. There we go. Okay, so what we're gonna do is we're gonna print some test objects, maybe benchy, maybe something bigger, maybe vase mode, and we will see how the PETG looks like. Because yeah, CF gives you this nice texture around and it hides layer lines pretty good. So one sip of water and let's do this. Let's unpack it. So the filament, it's our more affordable line and the materials are still very good. They are very competitive when it comes to the price and quality. So I have a lot of defilaments and I'm really surprised how good they are for the price you pay. So I also managed to convince my friends to test it out, and they also been very happy with it. So I think we will see the filament more and more in the future. Today we have simple blue color. It's not gonna be anything fancy. So we have a box, plain box with the logo. That's pretty much it. Then we have a sealed bag with the desiccant, so it's gonna keep the moisture on the proper level. And it's a vacuum bag. You can see it's still holding vacuum pretty good after so much time. I'm gonna just take a look on the label when it was produced. No, I don't have any date here, but maybe on the label on the spool we're gonna see it. No, unfortunately I don't know when it was made because it was sitting on my shelf pretty a long time, but it's still gonna need some drying, right? Because it's a PETG and you can already see on the spool that it's a bit shiny against the light. I can show it you from the close up. You see the shyness, right? And you see the texture from carbon fiber coming up. So yeah, there is a little bit of carbon fibers inside there. Okay, if you want to say hello or you have any questions, just drop them in the chat and I can help you out. Okay, so we have pretty nice blue color. It's not, I think it's gonna be warm blue, if you can imagine warm blue color. Hard to say anything more turquoise, going that way. Maybe it can be like a jeans a little bit. No, it's too warm for the jeans. Jeans are a little bit more cold. What we're gonna do, because this was with the in a bag, vacuum bag with the desiccant, so it's supposed to have at least 20% relative humidity inside. What you're gonna do, I'm gonna use the Prusa dry box to keep the filament dry. I'm gonna just unload the filament, this one, the filament, a filament, because I use the ABS Kevlar to print some extra parts for my solar panels, yes. how crazy it sounds, it's still possible to use ABS with Kevlar on stuff like that. And we're gonna use our small Logitech camera, webcam, to see what's going on inside. And actually, I'm using the Prusa Core 1 because it's enclosed printer. Okay, we're gonna just remove the ABS. And Kevlar, actually Kevlar, it's not as harmful as carbon fibers, but still carbon fibers are not that bad as everyone thinks it is. It's a bit of controversy, I can say, I would like to say, because I know that one YouTuber did a video about carbon fiber filaments, and suddenly every single filament with carbon fiber, it's bad, it's gonna kill you. Well, no, it's not. Oh, it's almost gone. The ABS, you see, half a spool went away. We're gonna store it later. And now we're gonna load up the PETG. And PETG, I'm gonna come back to the thing with carbon fibers in a moment. I just need to find the cutters. Oh, they no. Where did I leave my cutters? Here. Yeah, in the meantime, the filament, the carbon fibers, fibers are not that bad unless you're gonna eat it. No, I'm joking. There is a small amount of research that it is actually harmful for you, but there is no so much research. It's just like any plastic that it's warmed up to melting point around, I don't know, 250 degrees Celsius. Even 200 degrees Celsius will be harmful because it's making those ultra-fine particles getting airborne. Okay, 32%. We will see how much we're gonna get later on. And you don't want to inhale it. I mean, the printing should be done in an enclosed chamber with filtration system, and maybe the filtration for the room that you're printing, it's gonna be also a pretty good idea. It's not necessary, but it's recommended, right? So you don't want to inhale any fumes from 3D printer, even if you're printing PLA, because even when you're printing PLA, you're gonna get these ultrafine particles of plastic that comes to your lungs, because those particles are bypassing the our filtration system in our nose. So yeah, it's not that, you know, sunshine and rainbows, but it's not as bad. If someone will do a bit more research about how harmful it is, or how it is not harmful about carbon fibers, I cannot say anything more about it, because the situation where you get those fibers in your fingers, it's not that extreme as people say, because the people that made this video and they talk about carbon fibers, they didn't do any proper research. They just observed what happened. And it is Prusa, for example, the company, they did some research on their carbon fiber filaments, and this was a proper research with a proper amount of subjects, etc. You can see it, you can find it on Reddit, for example. But the thing is that all those small particles of carbon fibers in your skin, in your fingers, are just like a splinters coming from the wood. Your body will not, I mean, depending on the situation, but the splinters from wood, it's gonna act similar to the carbon fibers, because carbon fibers actually probably wood, right? In different form. Okay, we have, yes, we have proper color. So in a situation when you grab a plank, like unsanded, not painted plank of wood, you're gonna get some splinters in your fingers and you don't even notice it. The same thing goes with the glass fibers, because many things like insulation got glass fibers and it's itching. If you're gonna have a carbon fiber filament and you're gonna play with it, you're gonna feel discomfort, but it's not gonna be itching as much as glass fibers from insulation, for example. I touched it, I worked with it, so I know how it is. You need to trust me on that. So let's start printing, and I'm gonna talk more about this. I'm gonna just put the camera against the printer. There we go. Gonna watch cool stuff, what's gonna happen. Okay, let's hope this is enough. I also suggest to start with the benchy. So I will just use our slicer for Prusa. I'm gonna do this, okay. So one second, I'm gonna change the screen so you can see, what's happening here. I'm gonna just change it to the Prusa. There we go. Okay, and we go to the slicer. Here we go. Yeah, this is the items that I needed. Let's go with the test models, shape gallery. I think it was this one. And then we're gonna get 3D benchy, add to bed, okay. And then we're gonna change to balance 0.2 millimeter. And I think we don't have PETG with CF profile in the Prusa database, and I don't have it either. But we can use like a PETG matte, for example. I think it's gonna be okay. I'm gonna just check the print settings, filament, just temperatures. 85 on the bed, 230 nozzle first layer, and other rays 240. I think it's gonna be fine. And cooling, yeah, should be fine, I guess. Okay, let's not change any settings, and then we're gonna get like our test model so we can see how it's gonna look. Should be fine, right? I guess so. 45 minutes for some reason. It's gonna take a bit time. Okay. Yeah. Upload and print. Let's go. Should be good. It's gonna take some time to upload and start, whatever. We are ready, and then we can change the view to the printer, and more or less it looks like this. So yeah, the researchers that from Prusa, what they did is that they compared the irritation of the fingers and skin after exposing to filament with carbon fibers and compare it to the wood filaments or wood itself, like a natural wood, and it was the same. It was actually the same, and it wasn't that bad. Of course, there is some disadvantages or problems with the carbon fiber filaments, because once it's printed, it's getting airborne, as I said before, and you don't want to inhale it. This is the one problem. And the second problem is that you actually don't want to touch the filament before printing, because this is when the carbon fibers are actually exposed. But once printed, it's supposed to be inside the filament. Sometimes small parts are like outside the model, outside the filament, and you have some few different types of fibers. You have sharp fibers, and you have like not sharp, blunt fibers that are not attaching to skin, they are not going inside your skin. So those types that are like going inside your skin, they look like needles, there is very small amount of them, because those are the ones that are broken. They are like snapped in half, right? So this is very rare, because there's so much. If you're gonna see the video of the guy with his fingers and microscope, he got like, I don't know, few of them in his fingers, and they are really big. This is very rare. It's not happening very often. And you can imagine they are so small, the fibers are so microscopic, that if they are dangerous, you will have them like, you should have like a black finger out, you know. But anyway, you don't want to touch the filament, because you want to like minimize the risk of getting those splinters. And the other thing is that you should not like process the print after printing. What I mean process, I mean the post-processing, right? You don't want to sand it, you don't want to cut it, you don't want to melt it. It's supposed to be the part that just is stationary without any post-processing. Because anytime you will cut the part, anytime you will sand the part, you will release the small amount of those fibers in the air, and therefore you're gonna inhale it, or then you're gonna get it in your skin. So as Prusa said, I'm really like, I'm thinking that there's a really good stuff there in this article, that you should be also thinking in a way that if it's harmful, try to do some precautions, try to use safety gear just to be sure and safe. So any mask that you will help you avoid inhaling the carbon fiber while printing or while post-processing, any goggles, any gloves will help you. So this is pretty like a common stuff, right? This is common things to do. Protect yourself. And when you print a vase, if you print a benchy, whatever, it's not harmful to touch it. It's not harmful to see it and have it. It's not gonna do anything. It's just standing there. It's like, if you're afraid of plastics, you should throw away half of your house away, because there's so many ABS around you, so many ASA and nylon and whatever it is. There is so much stuff that it's not harmful, it's not doing anything to you when it's just there, you know. But once you're gonna play with it, you're gonna burn it, you're gonna cut it, you're gonna do stuff with those plastics, those ultrafine particles will just get into your system somewhere. Okay, we're gonna skip absorbing heat, we're gonna just go straight to the printing. And we will see how our cool benchy will look. Let me go to the display and we will see actual price for it. So explore the filament, practical, functional, spool and refill, value for money. Of course it is. See more. Let's go to the shop. And then we have all the filament that we have. Check this out. We have ASA carbon fiber, HTPLA, which is amazing. PETG, PETG CF, we have 6 positions. I mean, it's 6 colors. PETG light, we have 16 types, and HTPLA, we have 29. HTPLA, it's a really big stuff, you know. So, yeah, pretty good, pretty good. PLA, plain PLA 44. PLA with carbon fibers 14, PLA high speed 14, PLA light. PLA light, everyone was mistaking for lightweight filament. It's not, it's just like even cheaper version of PLA from the filament. It's the lowest cost we can get, and therefore it's very affordable. And we're gonna go there and now I can show you. We have TPU 82A, which I tested before, and it's really soft. Check this out. This is the penguin from the Linux. You see, this is TPU 82. You squeeze it and then it's working again. I can break it in half and it's working. Pretty funny. Yeah, let's see TPU at 92, 95. I think I need to see it. Okay. Let's go with the PETG CF because it's the most important thing right now. Let me see. We have gray, we have green, we have purple, then we have blue. This is the blue. This is the color, and it looks almost the same. I think it looks the same on the picture like in real life. The photograph did a really good job capturing this color, because sometimes the color is off on the pictures, and you should have like another picture of printed element to be sure, and also the monitor calibration with the colors. There's so much stuff to talk about. Whatever. Let's go to the another show. Let's show all, and we're gonna see everything from the Filament, because I love this new brand from us. PLA CF. Yeah, I did test PLA CF before. It's looking as good as PETG CF, but it's still easier to print because lower temperatures, better adhesion and stuff like that. So 27-28 euros for 1 kilogram of PLA with carbon fiber is not a bad price. But PETG with CF, it's still I think it was the same price. Yeah. So what are you thinking about, right? It's the same. Okay, we started printing. It started. We're gonna take a look in a moment. I just wanted to see before we're gonna leave the website. Do we have any TPU from the Filament available? Unfortunately, small quantity in stock, 87A. It wasn't on the list. No, it was 87, but we have also 82. Yeah, here it is. So we have 3 versions of TPU. Okay, so we have 87A, 2790 per kilogram. So it's a pretty good price for the soft filament. Okay, let's go to the printer. Let's see what's happening here. Yeah, it started. It started to printing. So far so good. It does string a bit, or I'm not sure. Maybe the nozzle was not cleaned. Hard to say. It's gonna take some time, so we can go back to the website and maybe we can see the data sheet for it. So I think it was download section, I guess. PETG, and then we're looking for PETG carbon. Yeah, I think it's gonna be, no, it's this one. So PETG have 3% high quality carbon fiber content. Let's see. The Filament PETG CF. Gravity 129 gram per cubic centimeter, so it is a bit more dense than other filaments, because normally you have 123, but this is marginal difference. Tensile strength at yield 57 megapascals. We need to compare it with something, because the only number doesn't tell me anything. Maybe we can compare it with as a different normal PETG and PETG Premium. Let's see the PETG Premium. So PETG Premium has, 1 second, tensile strength at break is 20 megapascals and tensile stress at break is 48 megapascals. So it means that the PETG CF is more fragile. I think it's gonna be more brittle. because of the fibers. That's pretty natural. And then we have tensile strength at yield. It's 57 megapascals, and this is 26 megapascals. I'm not sure, because my English is not my first language, so I'm not sure what does this mean. Maybe I can ask Gemini for it. But we have more here. Impact strength Sharpie method, 3.2 kilojoules per square meter. Do you have anything like that here? No, not really. Sorry. Okay, so this tensile stress at yield, it means how much we can force this material to deform before it's gonna not come back to original shape. So having PETG Premium with 26 megapascals and the PETG CF has 57 megapascals, it's twice as strong than PETG Premium. So pretty good. Heat deflection temperature, it's 70 degrees, and here we have 70 degrees as well on the same standard, D648. Closed chamber from printing, not necessary. Dry box recommended, no. Okay. Hardened nozzle, of course. Adhesive, not necessary. Cooling, 57 to 75 to 100%. Matte carbon appearance. Features 3% carbon fiber for durability and flexibility. Optimized formula, beginner friendly. Pretty good. Okay. So yeah, it looks pretty good. So yeah, I think this filament will do just great for example, any planters, pots, and anything that needs to be exposed outside with the UV and sun and weather. Should be fine, I guess. Let's see what the printer is doing. Yeah, looking pretty good. So far, so good. I really like this color. I think we have also the, I'm sure that we have ASA with carbon fiber from the filament with exactly the same color. So it's gonna be hard to find the difference in if you're gonna print ASA and PETG or even PLA from the same color with different filament, because they all contains carbon fiber, but it is still different material with the same color. Pretty funny. To be honest, we have 38 minutes left because the benchy has only 16%. I was thinking that I have more than one spool of this filament, then I could print on both printers the same material, and it's gonna be not possible because I didn't found it. I don't know where it is, or maybe I didn't have it. Maybe I mixed it with PLA because I have PLA CF next to it. Maybe it was PLA. I think it was PLA. Again, if you have any questions, if you want to know anything about Filaments or our brand, just let me know in the chat and I can probably give you the answer. Very quiet and peaceful day today. Outside in Poland we have actually right now 34 degrees Celsius. It's scorching hot, but fortunately there is some fan here and in the room it's not that bad. On this dry box on the Prusa we have like a gauge or display how much temperature the filament have and how much relative humidity it's inside the box. I really like this dry box because even Prusa advertised it, that it has like a museum grade seals that they won't let any moisture get inside, and you can print it. You can print with filament straight out of this box without taking it out. So pretty cool. More and more printers have these AMS systems, and you know, having dryers inside these multicolor printers. So far, so good. Let me read the description. The Filament. Series of 3D printing filaments created for enthusiasts who value quality, simplicity, and environmental responsibility. Is the perfect choice for those who want to bring their ideas to life without compromises, while also watching their budget and reducing ecological impact. The filament combines reliability and functionality, excelling in every 3D printing challenges manufactured in Europe. These materials shorten the supply chain and cut transport-related CO2 emissions. Spools are made from certified second life recycled plastics, and refill on a cardboard core lets you reuse your spool, fully compatible with Bambu Lab by choosing the filament. You opt for practical, sustainable printing solutions. So actually, Designismund, cześć, witam. Welcome back. Oh, okay, sorry. The chat was automatically translated to my language for some reason, and I was thinking you're Polish. Yeah, hello, hello. It was funny. The first time I saw it. YouTube made some updates recently. So actually, the filament, the spool for the filament, it's made from recycled plastic. So every single spool you're gonna see, let me just show you maybe this one. I was printing a lot of PLA with CF and HTPLA recently, and I didn't notice, but I did see that those spools are quite special. I mean, the texture, the color, everything about them makes now sense that it's recycled. Let me just change the... You see that spool? You probably seen this spool somewhere, because this design, I think it's very common. But actually this is recycled plastic. And the label on it is polypropylene. So it's pretty good material. Of course, it was casted, so not printed. And yeah, many manufacturers are using the same company to make the actual spools for their filaments, and this is why you can see the website on somewhere. But yeah, I should not talk about it, but I'm gonna just mention that we're gonna have our own spool. We're gonna I don't know if we're gonna... maybe I should stop talking now. I think it's confidential. I think we need to just wait for it and see. And then if I'm gonna get official information, I can let you know. Because it took a bit more time than I expected. But still, this line of filaments, I'm really happy with it. Because, yeah, the polypropylene, we have also polypropylene printable filament. I need to test it one day. Those spools are good for drying up in a dryer even up to 80 degrees Celsius. So having those from polypropylene or having those from polycarbonate, that will be good for any dryer. I mean most of the dryers, because if you have dryer that will go up to 100 or 120 degrees Celsius, maybe this is not the best choice. I'm not sure, I'm not printing in industrial printers, but we have industrial filaments. But even ABS Kevlar, like this one, was possible to print on Bed Slinger or on Cobra X, so it's pretty good materials, I need to admit. So this is PLA CF in the black color. I used it for the container and I really like the finish of it. It's a bit matte. And PETG will probably can be a little bit shiny. We will see. Let's see what's happening with the printer. Yeah, it's starting to get the second part of it. Infamous hull line. Jesus Christ, it looks so epic. I really like this color. On the webcam right now, it's a bit, the color, it's a bit off. Maybe I can change the position of the camera a little bit. Okay. So everyone can see it. Maybe even more, because we also streaming the vertical stream. What about now? No, too much. Okay, let's go back here. No, actually, it's supposed to be somewhere in the middle here. Yeah, here we go. And then we're gonna make it straight. Much better. And I also supposed to show you the penguin because I forgot. This is the penguin TPU 82A. Doesn't look that bad. Squish, squish. Squishy, squishy. It's very soft, but it's like it's hard to do with one hand because I'm gonna lost it. I'm gonna lose it. You see how squishy it is. Okay, let's go back to the printer. I'm not sure how many viewers we have from the vertical streaming position, but I need to maybe try to remember to show it on the right side so more people can see what we're doing, because you can imagine that someone is just browsing and they don't see anything on the stream. Sometimes it's just a bit disappointing. How do you guys feel about printing filaments with carbon fiber? Because probably we are divided in a people groups that they really like those filaments and the people that hate those filaments. Or maybe there's a third group that doesn't care. It's like, if you want to print it with it, just print with it. But nowadays, I mean, it's not a bad thing, but anyone can upload anything to the YouTube, to the internet, and it could be a false information, and it's up to us to discover what it's real, what it's not real, what it's proper research, what it's just like observation. So, you know, everything you see on the internet, you need to take with a grain of salt, that it's maybe real, maybe not, especially when you see this AI generated videos and stuff like that. You never know. What should we print next? Maybe we're gonna print some vase. I'm gonna take a look for some. I will take a look. Try to find some models. Oh, maybe we can print this funny experiment that I had before. Because I did phone stand and the container in vase mode. Maybe you've seen the video. The phone stand and the small container in vase mode that includes infill, inner wall, and top layers. Can you imagine that? But the phone stand will print a bit long because it's a big model. Maybe this one, the small container, this will be funny. Okay, we're gonna open as a project. We're gonna change the printer to Prusa Core 1, transfer the settings. We're gonna change it to our PETG. And then, is it working? Probably 52 minutes, doable. The bench will finish soon. You didn't print, you haven't printing with CF yet. Well, I'm not surprised. I mean, it's not that popular filaments. They are not that popular. I guess you need to have like special need to that for that. And I think the best way to pick the filament is to know what you're gonna print with it, because many times I saw people that they are buying the filament and then they are thinking what to print with it. I think the color is available. Let me just see on the website. Let me just go to the brands, the filament. You can check our website and you can browse, you can see. And then we're gonna just pick the PETG light and PETG, apply filter. And then we should see all the colors that we have. I think this one is different. And of course you don't gonna get the same effect, same color, because the carbon fibers gives you the texture, gives you this light bending effect, so it's not gonna be the same, even if the color will be similar. No, I think the color it looks similar, but if it's really the same, I don't really have this filament here. I think I don't have it. Just gonna take a look around. No. This is Pacific Blue PLA. Let me think. No, this is the green one. There's so many filaments. No, I don't think I have. But there is a small chance that it is the same color, but the picture looks different. I have also HTPLA from the filament, and I'm wondering if this HTPLA has the same shade, same color. Because we have ASA CF, which looks almost the same. Now, the HTPLA, it's different color. Yes, it's much different. So hard to say. If I could have two spools next to each other, then I will tell you the exact information, but I don't want to give you the wrong information and you're gonna buy the wrong spool, right? So sorry. Actually, the next print with the vase mode, it's gonna take 52 minutes, but the speed and the flow is very slow. So actual speed, it's 42 millimeters per second, so it's super slow. So what we can do, we can speed up the printing, and then we're gonna cut the time in half probably, because this is the PETG and it's gonna be super fast to print. And the flow, we have 4 cubic millimeters per second on the default settings, so I think we can go a bit faster. The external parameters, they are 50 millimeters per second, so if we're gonna go, I don't know, 90, so we're gonna cut the time in half maybe. No, it's still so slow. Why is that? Volumetric speed, it's wrong? No, it's 22. Or maybe just the shape doesn't let us go as fast. That's awkward. And maybe you can try to print it faster when you're gonna change the settings on the printer. You'll see. Oh boy, we have 56%, 19 minutes left. I would really like to turn off the automatic translation on the chat, but I don't know how to do it. At least the most of the stream is working, because last time I remember I had so much problems with it. Did you see our... I'm drinking water. It's so warm today. I'm just gonna show you here. The last video, because it's so amazing. I just need to share it with everyone because it's so cool. The last video that I made was this one, hacking the vase mode. I did internal wall, I did infill, and I did the top layer in vase mode just by doing 3D model with cutouts, and it wasn't that easy to do, especially if you have very complex model. But I'm gonna show you on the slicer here. This is the actual model from the video, and we're gonna print it soon here. And it's pretty funny. It's also in the video, so if you want, you can go to the video and check it out. Everything in the green, it's outer wall. So actually the printer starts in one point, which is here. This is the starting point. And then the printer goes here around printing this aka infill, infill and inner wall, goes around and then going another loop without retraction, without any travel, goes around. And if you're gonna pay close attention to the details here, those two walls are bonded together. This one not necessarily, because this gap was too big, especially, and also this one. but if you're gonna take a look, these two walls are bonded together and these walls are bonded together, so it works just like an infill. So it's reinforcing the material, and then each next layer is printed in vase mode, so you have no seams, no travel, no unnecessary retractions. Acid Fly Studios, hello, welcome back to the channel. My number one commenter on the channel. Thank you very much for each comment you do. I'm trying to reply to every single one that you leave, but sometimes it's impossible. Let's go further. And then when you're gonna go to the top layer, of course, in base mode, the slicer won't let you do the top layer because for some reason, I don't know why, you cannot force it. But if you're gonna fool the printer that actually what you're doing, it's the wall, the printer will start to print something like that. And actually, it's the same movement if you're gonna set the top layer and this wall. So it's so funny to me that the slicer won't let you print top layer, but it will print the wall that has the same shape. So this is like the bridging between one wall and the second wall. So it holds pretty good. And then we have another layer with the same pattern, but it's moved slightly to the one side so you can cover the gaps, you see? So maybe I can see it from here. This line, it's going on the gap. Each gap is covered with the next layer. So basically there's no gaps left. I mean, we can even adjust it a bit more in the CAD software to get more coverage. And then there is a small problem with this pattern because it's bonding pretty good on this side, but it's not bonding on this side because maybe it was my mistake. I didn't have enough time to do the proper model. So I added the third layer on the top of it. And the top layer is this one. It's a small two lines. I mean, it's one line and it's also the wall you can see here. And the funny thing is that in the vase mode, the printer won't do any travel, any movement, but actually it's doing the movement, it's doing the travel. If you're gonna check the legend and you're gonna check the travel somewhere here, travel here. You see those lines are the travel. So this is when the nozzle it's actually going around. And yeah, printing the last line, you see here, this line will be embedded in this layer. This one line will be going through this layer, and then it's going around normal a line that it's filling up with the other. Okay, let's turn off the travel, and it will fill all these weird comb-shaped holes and going back again because it's only the wall. We need to remember that. And for that reason, it's 0.2 millimeter layer height. It's pretty funny. So it's gonna be barely noticeable between this layer and this layer, but it will hide the fact that those small gaps are present. So it will just, you know, fill the missing area. So this is what we're gonna print next, and I will try to cut the printing time a little bit because 52 minutes it sounds pretty bad. Because the speed of this print, as I said, it's gonna be only 50 millimeters per second for some reason, but maybe it's just, you know, the shape, the geometry of it. Oh yeah, let's go to the printer. I forgot that we're printing the Banshee. Oh, it's almost finished. We have 74%, 11 minutes left. Pretty good, pretty nice. PETG CF, ladies and gentlemen. So yeah, if you want to see this video, you can go to our YouTube channel, and this is the last video that I uploaded 22 hours ago. So we have 201 views yet. The Z-axis anti-aliasing, it's also pretty interesting topic, but a bit useless. So I'm gonna spoil it to you. It's it's interesting, but you don't gonna use it. Maybe you're gonna use it once just to check it out, how it works. But this base mode, it's something that I was thinking about for a long time, and I managed to test it out. I generally think that printing without retractions and seams is very like high tech. I've seen only one video on YouTube when a guy was printing a cover for his electronics. Maybe it was Raspberry Pi, I don't know. And the whole thing was, of course, printed with 100% infill, or it was 100% wall, just like this model that we tried to print. And it was having no retraction. It was one continuous line in base mode. And he did it with the script, with the Python programming. So it was next level to me, unfortunately. I did it. I did my models in a plasticity CAD software, modeling software. It was possible. It didn't take too much time. You can do array modifiers, and it's going pretty fast. It's not that bad, you know. Can I make it bigger? I can make it bigger. Yeah, take a look. It's not that sharp anymore in this camera, but even in this quality of webcam, you can see this print looks amazing. I'm gonna show it to you on my main camera, but still, it's I think it looks just fabulous. It's never the same when you're gonna see it live. I mean, in real life, not over the internet, over the YouTube. So sometimes when I'm testing the filaments, any filament, the outcome is sometimes just amazing, because any different material, any different color, effect, silk, whatever, it can be much different from what you see on the internet. Eight more minutes, 82%. I'm so excited. I am also waiting for my Index 8 nozzle setup for Prusa Core 1. I'm wondering how it's gonna look, how it's gonna work. Not sure if the money was well spent. I'm sorry, I was taking a break for taking a new glass of water. Acid Fly Studios, maybe I didn't say exactly how to start on this video, but you need to think about how the vase mold works, because vase mold wants to print only the outer shell, the outer wall. So what you want to achieve is to create a shape that it will fool the printer that it's like the only outer wall going around inside and outside. And maybe I can show it to you somewhere. Maybe in a slicer. Maybe it will be possible to do it in a slicer. Yeah, let's try in the slicer in a moment. We're gonna just finish the benchy and we're gonna start with the new model, and then I will try to show it to you if it's gonna be possible or not. The main thing about... Oh, okay, I will wait. It's gonna take two more minutes, so don't worry, we will finish. Actually, we are promoting on the stream the filament, not the spectrum filament, but you're gonna put it here in front of the camera. Nice. Oh, we have sunshine here even. Okay. Okay, the chimney, and then we are almost done. Oh no, the printer, it's... Okay, we will leave it like this. And then we have a spool. But the benchy is almost finished. For example, yeah, you can, I think you can say that you are changing the infill to the outer wall and you're changing the inner wall to the outer wall. So you actually, the main idea, I'm gonna show it in the slicer. The main idea of printing inside, outside, and the infill is that you're taking this very tiny gaps, you're making those very tiny gaps in the 3D model, and when the printer are depositing the filament, it's so small gap that it's just bonding together, you know, the extrusion is so wide that it's gonna just bond together, and actually you're gonna have some kind of seam here. It's not a seam, it's just like a line, and then it's bonded, so you have an infill without any retraction or any movement of the nozzle. Okay, our bench is ready, so we're gonna move the camera back a little bit. I'm gonna open the thing. Okay, it fell down, so it's easy to remove. I can assure you that it's easy to remove it. Oh, still hot, still hot. Okay, ladies and gentlemen, I think I'm gonna start printing directly the other model, so we don't gonna waste any time. Boom. So we're gonna send it to the printer, upload and print. Okay, and we will take a look on this one, on the benchy. I'm looking for something that will... tweezers. Let's go with tweezers. Okay, it's let me move my bottom. Why the focus doesn't work? the light coming from the top, it's not very beneficial to show the layer lines, but it's still the overall finish, it's just amazing. All the details, overhangs, and yes, it looks just perfect. Let me see the back. Is there any? Can you see any any letters there? Because probably not. Come on, focus. Doesn't look that bad, but overall the 3D model looks amazing. And let's talk about shyness, because the PETG likes to be shiny, and this carbon fibers. Explain me that, how it's possible that only 3% of carbon fibers is making this filament look matte or satin. I see. Wait a minute. I have Z layer height spot where the floor stops. Not sure. Not sure what you meant by that. You mean the printer model, or not sure? You need to elaborate. Yeah. So it has this matte finish or satin effect. It's not shiny, but it's not also matte. So the light, it's bouncing out of it. I really like it. You mean the Z line on the floor, on the benchy? This is what you meant? I know the benchy has some issues on each printer, on each filament, and it's basically the whole line that is going around here in the front. There's some Z dragging on the floor, and the back letters are very hard to. It's hard to see the details. Oh yeah. So this is the whole line. Yeah. It's a very popular problem. I saw that people are trying to solve it, but what's the point? Okay, so we have a bench ready, and we're gonna start print our vase mode, and I can try to show you how to do it. I mean, let's go to the slicer. So let's try to add a primitive, add a shape, and we're gonna do a box, and this is gonna be our bottom box. So let's go change the height to 0.4, whatever, and then we're gonna add parts to it, and it's gonna be box again. Move it. It's not gonna be perfect, but it needs to just like show you how it's gonna work. So we're gonna change this size to 4 millimeters, for example. Or no, wait. Yeah, we need to do it like this probably. Or no, maybe we can do it this way. So maybe this. Wait, I'm just thinking loud. Okay, let's take the box, and then we're gonna do a negative volume, which is this box, and then we're gonna play with this a bit. So we're gonna change it to, if we want to have at least 5 millimeters on each side, it's gonna be 15, and the top will be 24, and then we're gonna move it to the up. Yeah, and so this is gonna be, I'm gonna remove this one. and this is going to be looking like that. So actually we already have the inner wall, but we don't gonna have a top layer. And what we want to do, because here we're gonna see that there is a lot of movement between those two walls, right? So it doesn't make any sense to me, at least. Yeah, and also when you're gonna see the layers, this is the third layer, this is the fourth layer, fifth, it's outside, you see, and the next layer is this one, and it's I think it's in the air. It's not holding to this layer anymore. So the good practice is to go to print settings and just add one more bottom layer, and it's gonna be welded together. So this is the small things that you should consider. Yeah, now it's finished, and all immediately it's going to this one, and then you see the movement of the nozzle. It's jumping here and there. So what we're gonna try to do is gonna try to add another negative volume, which is gonna be the box, and we're gonna change its size to as small as possible, 0.01 millimeter, and we're gonna try to cut it somewhere here and go up here, and we're gonna have this cut, right? So actually what's happening here is that the 3D model have insights right now here. We did the same thing actually with the negative volume in a center position, and then if we're gonna cut it, okay, I did a little bit too low, but now you can see that the nozzle is going around on the inside and the outside. And here we have a bit of too much space. So by the Swedish guys that was playing with the vase mode, they said that it's good to change this size, the cutting size, to 0.01 millimeter. So it's gonna be super tiny. Okay, it doesn't work that way. So yeah, it's infinite size. Okay, 0.01. Okay, it doesn't work anymore, it broke, so we need to add it more again. Add the negative volume box, and we're going to change it to 0.01 because this is the smallest amount we probably can get in the slicer, and also depending on the settings, it's gonna be welded together or it's not gonna be welded together. This is the point. So going to the advanced tab, we can see the slicing gap, slice gap closing radius. Sometimes when you change it to 0, it's not gonna close any gap, but we didn't have closed gap here, so 0.01 was fine. So we don't need to do it. But let's try to increase the perimeter extrusion width to 0.6. I mean the external parameters to 0.6 and see what's gonna happen. And it stays, so because sometimes this space it's disappearing and it's going to the back. Exactly, this is what you said. We're gonna use the one cutter that goes like this, just one cutter around. So the slicer thinks that the inside of the model is here, right? And then if you want to do the reinforcement, the infill, you're just gonna do it a small cut, not all the way through. So let's add the shape, and we're gonna add, we're gonna do the negative volume, and we're gonna use the cylinder, for example. And we're gonna make it a bit smaller, not too small. Let's try with 3 millimeters. And we're gonna put it somewhere here, for example. Oh, it's gonna be pretty hard to actually do it. Wait, one second. I think we can go like this, and we're gonna try to make it work. We need to go as close as to the outer walls as possible, but still we want to get between here, but still be able to open this here, you see? And then the wall will go around and like here. So let's see, yeah, almost. I almost did it. I think a little bit smaller. Almost. Because the extrusion rate is also a bit bigger now. Okay, it doesn't work that way because it's a bit too big. Almost there. Almost there. Oh, now we have it. Something like that, not exactly the same. I'm really happy that you understand now. So those walls are gonna get welded together, you see? So this will be our reinforcement. And the closer this gap is, that it's a higher chance that they will weld together and it's gonna act like a infill, right? So this is something like that. The top layer, it's much more complicated to do because you need to do exactly the same thing on a flat surface. So you need to do a lot of cutouts, and the layer, the nozzle will go like this, up and down, up and down, up and down. And your question is that, can you do it on different models? Actually, you can. But it's still a manual job. You need to do a lot of stuff like this. I mean, not in the slicer, but in 3D modeling software to create those connections. I didn't do it myself. Maybe I will try to do it. But sometimes it's very hard to do the vase mode because you want to have this one extrusion. So if your small figurine or your small character has different areas, how can I tell that? For example, the benchy. The benchy will be almost impossible to do, for example, because you have these 4 different posts, right? A pillar, B pillar, B pillar, C pillar, D pillar, and there is no connection between them. So you need to have jumping nozzle anyway. So you're not gonna do it, so it's not gonna be possible. And anything that needs to have supports or bridges will be very hard to do. It's not impossible, but you will need to figure out how to print it. Because if we're gonna take in the slicer, let's take the benchy. You probably can't print benchy in a vase mode, shape gallery. Let's take the benchy. Let's see what's gonna happen in a vase mode. I think it's gonna be just missing some parts. Yeah, it's missing a lot of parts because the nozzle don't want to actually do retractions and go around. What's that music? Too sad. Okay, let's start from here. Or here. I just need to fix the music, sorry. Oh, here is the playlist, okay. I'm not sure if you're hearing the music, but maybe it's good that you don't hear it. Yeah, so let's go back to the vase mode. The printer doesn't want to go to the different places. This is why it looks how it looks. So you don't want to print stuff like that. It's also trying to do the slopes, the connection between them. So if you will be if you manage to make a connection between all those parts, it's gonna be possible to do that. you need to do the proper cutouts here and there, so after that it will work. For example, let me try to do an example at the negative volume box, and we're gonna try to do it with 0. No, it's not. It's this one. 0.01 millimeter wide, and let's just try to cut it here, and we will see what's gonna happen. On even more, all the way there. I'm gonna change it to 40, and let's see what's gonna happen now. Not too much, not really too much. Maybe it's too high. Let's try to put it lower. Still nothing. For some reason. Maybe it's because it's a planar layer. What if we're gonna put it in the front? It looks even more different now. But actually what we can do is, if we change this height to 0.2 millimeter, we have this weird line, right? And if we're gonna put it somewhere, I'm just thinking loud. Let's try to rotate it 90 degrees. And let's see what's gonna happen now. Now we have a bridge, you see? So playing with this that way, yeah, we have a bridge, but now we have a missing layer. So actually what we should do is that we should go not all the way. I don't see the shape anymore. Oh, okay. Hard to say where it's ending because... Okay, now you see we have layer and we have this extrusion here. So even if you're gonna try to move it a little bit more, just to connect with the other line. Okay, a little bit more. And then we're gonna copy and paste and paste and paste. We're gonna create a planar surface in vase mode. Something like that, but it's still missing, right? But we need to go as close to this wall when it's gonna just connect to each other. So somewhere here maybe. No, too far. So a jar with 10 millimeter thick wall, and I want to change the infill into open space between inner and outer walls. Not the total space, but like the wing you showed in the short. If you want to do it like this, then you need to cut it on one side, as I showed you before. And if you want to use the infill, it's gonna be the cutout only not all the way, right? Like this. So is this correct? I think this one is correct now. So the layer stays. Yeah, it's going back here, but it's welded together here. We can even inspect this one layer. Yeah. So the nozzle will go, you see here, it will connect it, the bridge, it will go back, and then it will continue to print in one move. And then what you can do, I'm not telling you to do it in the slicer, this is going to be a very bad idea. You're going to copy and paste the same line and go a bit further. I calculated, for me it's going to be 0.7 millimeters, and then you have the second extrusion, and suddenly you're starting to get this planar shape, right? So if you have enough time, you can do it, but people are making those models in programming style. They're making scripts, they are calculating the G code itself. Maybe AI will help you to do that, and it's gonna be possible. But you get the idea, right? Let's do the cylinder idea. So we're gonna do a big one, let's say, and then we're gonna go with the negative volume cylinder. Okay, the slicer is pretty funny to work with, but it's still doable. Yeah, exactly. The Tinkercad or Blender will do just fine. It's not that complicated. I just want to see where it is. I'm not sure. I'm not even sure, because this one has 95. So we should have, if we want to have 10 millimeters on each side, it's going to be 20 less, so it's going to be 75. So 75, 75, something like that. And then we have 10 millimeters wall. Great. And then we should put it upstairs a bit more. Okay, maybe like this. And then we're going to cut it with the box, negative volume box. Of course, it needs to be higher, and 0.01, and this should be enough to cut it here. And also we need to go a bit higher. Maybe this one is too big. The Z, no, okay, we need to have 100, I don't know, 20. Oh, I didn't see it. Okay, let's try to move it up just a tiny bit. And then we're gonna have, as you said, the double walls and no extrusion, I mean no retractions, right? So we're gonna take the travel to see the travel, and then we're gonna see retractions and de-retractions, and there is none. You don't see any retraction, any de-retraction, any seam, right? Yeah. There's only one seam down there, and the movement is on the bottom when the nozzle is trying to do the bottom layers. So this is how it is, and this is welded together. So as I said many times, this looks like a seam, but it's actually not a seam. And for many times, if you're gonna the wing is a good idea. The wing is a good example. I'm going to show you the wing. Because the wing, I supposed to show it on the video, and I totally forgot about it. This is the wing from the video, and if we're going to do the vase mold, let's slice it. It's exactly like on the video. You don't have the top layer, and it is connected here, and you can try to inspect the whole model. It's gonna take 82 grams of printing. Yeah, exactly what happened with this container. The gap was too big, and it didn't manage to weld together these walls, right? So going back to the wing, we have 82 grams of material and 3 hours of printing. And let's try to turn off the vase mode, but leave the 1 perimeter and 5 bottom layers and no infill. And check this out. What's gonna happen? It has 92 grams and it has 4 hours and 14 minutes of print time. All because the printer will try to increase the amount of filament here and there where it's needed, and you're gonna get 24 minutes of travel here between those elements. And this is the same model, right? And you're gonna get 10 grams more of filament just because the printer wants to get overhang parameter. No, it's a solid infill. It's 13 grams more and 30 hours, 30 minutes more. So it's pretty funny. And then we're gonna go back to the spiral vase. It was 4 hours 14 minutes and this was 3 hours. So this small change, you can imagine what's gonna happen if your models can be printed that way. You're gonna save so much time and so much filament. A solid infill here is only on the bottom and the travel is only 32 seconds. Can you see the difference? It's so much. Okay, let's go to the printer because I totally forgot about the printer. Yes, we are printing. I'm just gonna go here. I would like to show you maybe from the top because it's gonna be looking very interesting from the top. Maybe like this. Something like that. So you see the movement of the printer. Exactly like in the slicer. It's going around, it's making those inside shapes, no retractions, no travel, just pure printing one line. I'm so hypnotized about this that it's hard to comprehend. Okay, I'm gonna take a very short break. I need to take care of my dogs. 1 second. Sure, Acid Fly Studios, thank you so much for stopping by and talking with me on the chat. It was a very pleasure for me. I hope you will be well with your doctor appointment. So thank you so much and see you in the next one. Hi Ians, yes, no problem. I think it will be it's okay, it's going fine, so no worries. It's not gonna clog. It's gonna be just fine. We have 26 minutes more. We have 50% done. It could be faster. Oh yeah, we're supposed to try to speed it up. Let me tune the printer. Let's do the print speed to 125%. What's gonna happen? It's gonna go faster. It actually does. It's printing faster. Hello, Damian. The supervise mode. Hello, hello. Yes, the most epic vase mode ever created. I really like it. It's so hypnotizing. There is something in 3D printing that bothers me, especially the seams, the retractions, and, you know, the stringing and stuff. So what I'm gonna do is I'm gonna use the supervise mode that you said, and I'm gonna use it for the lightweight ASA and lightweight PLA and print some cool stuff with it. Especially for the form next, we're gonna print a lot of new 3D models for it. I think I should start printing now. Last year, I think we started somewhere in August. "4mm smooth glass with some mods made cost me..." Jesus Christ. But it's glass, right? It's not a polycarbonate. It's gonna look premium. Premium as hell. You know, when I'm talking with my wife about my hobbies, it's like, it's a hobby, so I'm like allowed to spend more money. What color did you pick for your Voron? Or you're the guy from the Discord that has this black and yellow one? Okay, so it's not you. Gray frame and the black elements. You know, it's gonna look very futuristic, I guess. I like combining black and gray. It reminds me of like Ghost in the Shell movie and cyberpunk stuff. Okay, we have 20, how much time left? Because I sped up with 26%, but the color didn't change when we changed the speed, so it's good. 17 minutes. So actually, we saved 10 minutes? Is it possible? It looks awesome. It's gonna be awesome. Plus A4T is awesome. What's A4T? A4T tool head. Oh, this one. Looks cool. Yes. Another for tool head. No, another for 4010 tool head. Okay, so you must be very advanced user of a 3D printer and very experienced user. Printer. You are the 3D printer. Enthusiast, I should say. Okay, I'm gonna take a look on my dogs again because I think someone is playing with my dogs outside. Spectrum ASA is your favorite filament. That's very nice to hear. You mean ASA 275? I think ASA 275 is the best layer adhering ASA that I ever seen. Because most of the time when I picked ASA before, the layer adhesion was so bad that it was basically pointless to print. And ASA 275, it's amazing. It's just working. And I love when something is just working out of the box. I have 4 white dogs and they are leaving their fur everywhere, and I need to change my shirt to white one, so it's not gonna be that visible. Because on the black shirt, it's... I hope you don't see it on the camera right now, because we are streaming, so the quality it's a bit lower. But on the videos, if you're gonna take a look, you're gonna see a small fur somewhere here and there. Let's go back to the printer. I recently started to print with ABS with Kevlar, and I did print with nylon, and I really like the ABS and this nylon. It's so strong. I didn't expect it's gonna be that strong. Suddenly the other filaments are just like fragile. But maybe PLA, the HDPLA from the filament we have, this high temperature filament, this is very tough as well. It's harder to break than PETG or PLA. So if I need to print some like durable part, last time, I think it was yesterday, I printed the GoPro mount for my helmet, and I used just HDPLA, and it printed in 30 minutes, and it's just perfect. And it's very tough, it's not breaking, it's not, the layer adhesion is just amazing. Maybe it's similar to PLA 2.0. There is some additives in the filament, you need to be aware of that. It's not like cleanest PLA. But we did some testing, like outdoor testing on those filaments HDPLA, and it was 30% stronger than PLA and about 25% harder. So I was really surprised. But we did try to break it on the form next with the spatula for the bed. We've been printing those, and people were trying to... I was encouraging people to try to break it and see how hard it is to break it. And they broke it, and they said, yeah, okay, this was hard to break. They were surprised that this was PLA. Because normally you know that PLA is just fragile. The only one issue with HDPLA is that sometimes when you have a big print, it can warp on the corners. So you need to use the brim, or you need to use the glue. This is the only one downside of this filament. But most of the time, when you're printing vertically or you're printing small items, no problems at all. And even if you're printing on any printer, the heated bed's supposed to have maximum 50 degrees Celsius. Or if you have a frostbite, the blue plate, it's gonna be even lower. It's gonna be 30, 40, and it's gonna be fine. You don't need to have more. So printing bigger parts on the blue bed will be a very good idea. We have 73% and we have about 10 minutes more, and we're gonna inspect our small part, and this will be the end of the stream within probably 15 minutes, I guess. So to sum it up, the PETG CF from the filament, it's super easy to print. You can use generic profile for PETG without any problems. It's going to be about 250 degrees Celsius on the nozzle, about 90 degrees, from 80 to 90 degrees Celsius on the bed, and it's pretty fast as well. I didn't test the speed. So you can imagine how much time we need to spend to create one video when we're testing so much stuff about one filament. It is full-time job. It's fun job, but it's still a job. Acid Fly Studios, unfortunately he went away, but it's very good idea also when you're printing in this super base mode, quotes. If you change the extrusion rate of your filament to 1.05, so you're adding 5% extrusion. So if you cannot, for example, change the width of your extrusion because the gap will be open, you can increase the extrusion, and then you're gonna get more filament between the gaps, and they will bond together, they will weld together, and it will work pretty good, especially for the top layer when you're planning to do the top layer in vase mode. I think I'd used once on this red container. It was the filament had in extrusion 1.1, so it was 10% more extrusion rate, and it was perfect. Almost perfect. Now I'm looking at the thumbnail for this hacking vase mode video, and I think there is missing a scale factor. But there is a small shadow of the nozzle in the first picture. Jesus Christ, this video had 30 minutes. I didn't realize that I was talking about vase mode for 30 minutes. It's so funny. I hope it's not bothering you guys that we are making videos about 3D printing and promoting our filaments. I think it's just natural way to show our products. We are not pushing anyone and forcing anyone to buy our filaments, but I really believe our filaments are really good. And they are made in Europe, in Poland. This is pretty good factor. You can get it faster. And if you're gonna pick the filament line, PLA light or PETG light, you're gonna save even more. Yay! Super vase mode in progress. 7 more minutes. The surface of this model looks just amazing, but maybe because the light, it's going straight to the wall, not from the top or from the bottom. We're gonna watch the model pretty soon. And the sun is setting. Sun goes down. The day is ending. I have 8 o'clock here in Poland. 8 p.m. I should say. because on some other regions you're gonna get 8 a.m. Imagine that someone is waking up and Jesus Christ, you're streaming so early. What the hell? I want to leave the camera right now because soon we're gonna get to the top layer and it's gonna be looking very funny. I'm gonna even try to enlarge it. See this one? Let me try to enhance the video even more. Okay. Now, I think it's not gonna get any sharper now. Okay, this probably is enough. And very interesting thing about HDPLA from the filament is that it's not doesn't smell like any other PLA, because PLA has this sweet different scent and HDPLA has this different smell. It's not unpleasant, but it's not also the nice sweet corn. It's different. Okay, 4 more minutes. I think it's gonna take about 2 minutes to finish the top layers. You will see. Yeah, the wooden filaments are the best. But it's, you know, VOC and ultra fine particles in the air, so it's funny how people are overreacting when you're thinking about fumes going out from the carbon fiber filaments when you're printing ultra fine particles, but you can stand next to the grill and you can stand next to the fireplace and you inhale this burning, you know, wood and other biological stuff, and it's fine. Or even worse, you going to the city and you inhaling those fumes from diesel cars. So it's not that as bad, you know. 3 more minutes. I think we're gonna start to print the top layer soon. In vase mode, remember that. Takes more time than I expected. 2 more minutes. Almost finished, almost there. 1 minute, 95%, so it must be somewhere. Now it started. Now he's printing the top layer in the vase mode, aka the wall, the top wall. So far so good. You can even try to do like more than one layer of that and it's gonna look even better. I also seen that some of the slicers can be adjusted with the flow of the top layer or whatever, but the problem is that the slicer thinks this is the wall, so you cannot change any settings for the top layer or you know, the infill. It's gonna act like a outside wall, outer perimeter. And then the second one, now fill in the gaps for some reason. So it's actually not a wall, it's not the vase mode. But it is printable. And now we are covering the gaps with the next layer. It's not gonna, I think it's not gonna look as perfect, but it is covered. I like that. And then the last lines, and we are done. Here we go. Okay, let's see how it looks. Remember when I was trying to remove the Banshee from the bed and it fell down? This one is sticky. Okay, it's probably bigger, that's why. Boom, we got it. So as I said in the beginning of the stream, it's okay to touch the filament with the carbon fiber. It's supposed not to get into your fingers or skin, whatever. You don't want to post-process it. You don't want to sand it. You don't want to inhale the sanding parts. You don't want to cut it. You don't want to break it. So visual appearance, why not? Some, you know, simple prints, okay, or the parts that will not get broken. Okay, what do you think, guys, about this item? Let me move my bottom to the camera. It's a bit shiny. You can see the reflecting light. You can see the texture, carbon fiber texture. Actually, the light is coming from that way, so if I'm gonna put it in this angle, it's not gonna be, the layer lines will be invisible. And now we have the top layers of the vase mode here. Good enough, I guess. And the finish of this, it looks really good. And PETG with CF, it's gonna be much more, you know, harder. And maybe we can do the simple test when it's gonna break. I have a PLA. No, I cannot have the same color. Okay, let's try with this one. This is exactly the same model. We have a PLA. How many filaments, spool of filaments will hold this one? So we're gonna take like this. It will even break. I'm not sure if this is a good idea. I will need to have more filaments or more boxes. Okay, if this is gonna fall down. I don't think it's a good idea because it's gonna take like, I don't know, 50 kilograms to break it. So we're gonna drop that idea. But you can already see that it's harder to squeeze. So actually the data sheet was correct. So it is a bit harder. Ladies and gentlemen, this was the Filament PET-G with CF in the blue color. We have it in our dry box and Prusa Core 1. And the finish of it, it's really good. And we have a benchy and we have this container printed in vase mode. So overall, I really like the finish, I really like the color, and it was super easy to print. So I really can tell to just buy it, just take it. I don't think we have it in stock. Let me just check. Yeah, this was the YouTube channel. I think we didn't have any single one of it. PETG CF, we have only 6, and I think it was missing. Yeah, it's everything is in the back order. Sorry, but this is this one. Next time I will try to pick the filament that we actually have in stock, and you can buy it straight away. But I need to tell you, because for me it's amazing that there is people that never heard about it. We have PETG light and we have PLA light, and those filaments I'm printing daily with those filaments, and people are telling me that if those filaments cost 12 euros per 1 kilogram, they are not good. They are good, you need to believe me. And if you're gonna see the blue dot next to the filament, it means that it's not in stock. But if it's yellow or green, go for it, buy it. And let me try the green one. For example, it has the green dot, and you can take a look. If you're gonna buy 10 rolls or more, you get promotion and you're gonna get 15% off. So it's even better. But if you want to get 10% off of everything we have, even with one spool, you can use our code SpectrumYT10 on checkout to get 10% off. Because if you buy 3 rolls, you get 5%, and if you're gonna buy 6 rolls, you get 10%. So you can be smarter than everyone else that doesn't know that, and use our code. So you're gonna add this one to the basket, go to the basket, you can use our code Spectrum YT10, apply it, and then you just saved €1. But if you're gonna get more, you're gonna get even probably free delivery, but free delivery is from 60 euros or something like that. Okay, let's go with 5. 10 euros left. Okay, let's go with 10. Yes, and we have free delivery and we saved 30 euros. But if you're gonna remove that, we should have a better deal without this one. Let me refresh the page. 17. This discount is connecting me to each other. Can you imagine that? Sorry. Yeah, they are connecting probably, but it should have 15%. Maybe I broke something. I'm exploiting my own work. This is so funny. But you see, you're gonna get 9 euros for one spool of PETG or PLA. So this is amazing. Okay, guys, I need to finish the stream. So thank you very much for joining me today with printing PETG with carbon fibers. This was the filament, and it contains 3% carbon fibers, very fine carbon fibers. And it was easy to print, as I said before. So please check it out on our shop, pick it up if you want, and remember to subscribe to our channel, like this video if you liked it, of course, and leave a comment if you want after the stream. So I hope we On the video I can cut this out, but on the stream it's impossible. When I'm talking so long, yeah, my tongue it's twisted. I hope we will see each other in the next one. That's what I wanted to say. Thank you very much and goodbye. It was funny, right?